Welcome back to our series of lectures. Now we are on solving an absolute value inequality using theorems. Previous to this video, we solved absolute value inequalities using the definition of absolute value. Okay, so the theorems that we will be using here will be the following. Absolute value of triangle less than k, provided k is greater than equal to 0, will give me triangle in between k and negative k. And number 2, absolute value of triangle greater than k greater than 0 implies triangle greater than k or triangle less than negative k. Again, we will not consider the trivial cases where k is a negative number, or we can consider when k is 0 here. Okay, so let's have an example. Suppose I have here 2x minus 3 less than 5. Now, this one here is my triangle, 2x minus 3. And then my k is 5, which is greater or equal to 0. Which means I can rewrite this without the absolute value symbol by using this theorem. And I will get here 2x minus 3 in between 5 and negative 5. Then, it's our turn to solve for x. We may not split this inequality because the variable is just located at the middle. We can just say addition property will give me negative 2, and this is 2x, and this is 8. Okay, and then I will solve for x, so I'll multiply everything by 1/2. 1/2 is a positive number, so this sense of the inequality here will be preserved. And this gives me a negative 1, this is x, and this is 4. Therefore, our solution to this inequality will be from negative 1 to 4. You can write that as negative 1 to 4 graphically, or you can have it as an interval solution, negative 1 and 4. Alright, now suppose we are going to have the opposite one. Okay, we will use theorem number 2. 5 here is positive, so we can use this theorem. Okay, now we can now say, according to the theorem, 2x minus 3 is greater than 5, or 2x minus 3 less than negative 5. This is greater than k or less than negative k. And then this is 2x greater than 8, or 2x less than negative 2. X greater than 4, or x less than negative 1. Hence, my solution here is from negative 1 to negative infinity to negative 1 union from 4 to positive infinity. That's again the complement of this solution here. Less than and greater than are complements except the endpoints, negative 1 and 4, which don't belong to either of these two inequalities. Let's say, for example, the trivial case, suppose this is greater than 0. Because our theorem says greater or equal to 0. So suppose k is 0. This is trivial because I will say that this is all true except for x equals 3 over 2. Now suppose we will use the theorem. It will be 2x minus 3 greater than 0, or 2x minus 3 less than negative 0. Or this is x greater than 3 halves, or x less than 3 halves. So what is it saying? X greater than 3 halves is going to the right, or x less than 3 halves going to the left. The only solution that's not included is x equals 3 halves. From our trivial case, this is always true for all x except x equals 3 over 2, because when x equals 3 over 2, what happens? This will become 0, and 0 is not greater than 0. That ends our discussion on absolute value inequalities. See you in the next video.